Okay, so in this case, we've been presented with a hydrocarbon and we've been told that it's got a molar mass of 40 grams per mole, right? And we've been presented also with the empirical formula C₃H₄, and we've been asked to work out what the molecular formula of this hydrocarbon is. So what do we know? We know that the empirical formula is going to be effectively the simplest, or albeit the smallest, whole number ratio of atoms of elements in a given compound. And we know that the molecular formula is going to be the actual number of atoms of each element in that same compound, right? So we're effectively going to look at, well, what's the actual scale factor between the empirical formula and the molecular formula? We need to work that out. Is it going to be 1x, 2x, 3x, 4x? And when I say 1x, I mean it literally is a case of, well, is it actually just the same as the molecular formula? But we're going to need to work that out in any case, whatever the situation. How am I going to approach this? Well, the first thing I'm going to want to do is work out the molar mass of the empirical formula I've got given here in the question. So in this case, we've got C₃H₄. So to work the molar mass out, I'm going to need the relative atomic masses of carbon and of hydrogen. Now, you may already know what these are because, given the commonality of carbon and hydrogen. However, I am going to refer here to the periodic table and then kind of show my working through the entire process, right? So relative atomic mass of, so we've got hydrogen here, we've got carbon here, and just for the sake of convenience, I've got them here as well, right? So for carbon, we've got a relative atomic mass of 12, and for hydrogen, we've got a relative atomic mass of 1, right? And so what I'm going to effectively do is I'm going to say, well, what's the molar masses for these? Well, the molar mass in this case is just simply the same as the relative atomic mass. So for MR, and I'm going to use MR, right, for molar mass, MR for carbon is going to be equal to 12.0. That is not written correctly. It's going to be 12.0, and for the MR for hydrogen is going to be 1.0, right? And in when we now consider these relative to the question, we need to do some multiplication, right? So we need to set up a calculation here. So what I'm effectively going to do is I'm going to take the atoms, multiply the molar masses we've just been able to determine, multiply it by the occurrence of that given element or given corresponding element with the number of times it occurs in the empirical formula, and then I'm going to add the 2 of those for each of the elements, right? So for carbon, let's set up the carbon part. So that's going to be 12 multiplied by, here we've got a coefficient effectively of 3, so we're going to be 12 times 3, and we add that to the corresponding for hydrogen. So in hydrogen's case, we've got 1.0, right? So we're going to have 1 multiplied by 4 in this case, right? And so that's going to give us our molar mass. So if you have a go, work that out and see actually what the outcome is that you get. Now, if you work that out, you're actually going to find that your answer is going to be 40, right? And so therefore, because it's 40, what we can say is that the MR of our empirical formula, or the MR of, in this case, C₃H₄, is equal to 40, right? Now, is this the MR of our the molecule that our molecular formula is going to give us? Well, based on visual inspection, if you look at and you compare this, which is going to be, let me just put the units as well. We've been told that for the molecular formula, the MR is going to be 40 grams per mole. So far, we've worked out the empirical formula's molar mass, and we've got 40 grams per mole. It's the same, right? Traditionally speaking, in a calculation like this, you may want to have a go at dividing the molar mass of the given molecular formula by the molar mass of the empirical formula. Although it may well be a redundant step, but we can have a go anyway and see what we get, which we know we're going to get, but we can have a go anyway. So in this case, 40 divided by 40 is going to give us what? Well, it's going to give us our multiplier, which is going to be 1, right? So 1. So the multiplier is equal to 1x, and therefore the empirical formula is equal to the molecular formula. Right? So what does that mean? All that means is simply that the molecular formula is what we've been told is the empirical formula, simply because the multiplier is 1x, right? So therefore the molecular formula is C₃H₄. Okay, so in this case, because of that 1x multiplier, the molecular formula is actually in this case the same as our empirical formula. Okay.